What's up, guys? So in this video we're going to be covering how to solve two sets of linear equations through substitution. Substitution is one of the most popular ways of solving systems of linear equations. And we have an example for you here. And these two equations are 2y plus 3x is equal to 20 and y equals x plus 5. Now, we're going to be using the substitution method once again to solve these problems. So I'm just going to write substitution up on the board. Okay, and the first step that you have to do while solving linear equations through substitution is make sure that you are isolating either one of the variables. So we're going to take the easy way out, and we're going to take this equation right here. Y is equal to x plus 5. If y is equal to x plus 5, that means you're basically having an equation that's basically saying that if you substitute x plus 5 for y in the next equation, you will have isolated the variable. And by isolating that variable, you can easily solve the system. So if we substitute y for x plus 5 in this equation, we can say 2 times the sum of x and 5, close parentheses, plus 3x equals 20. And now in this equation, we have just changed it so that there is no y in there. And now I hope you guys know how to solve equations with only one variable, but I'm going to show you anyway. 2x plus 5. We can use the distributive property over here, the distributive property, and we can solve it. The distributive property basically states that you can distribute the numbers inside the parentheses to the numbers outside the parentheses. So we multiply 2 with x and we multiply 2 with 5. 2 times x is 2x plus 10. Now we solve that, we can just add this on. Plus 3x is equal to 20. Okay, so now we have 2x and 3x. What we can do now is add them to equal 5x plus 10 is equal to 20. Now what we have just done is adding these two variables with the same base and different coefficients. So we're basically adding 2 and 3 and adding an x over there. So our equation becomes 5x plus 10 is equal to 20. I'm going to continue this over here. 5x plus 10 is equal to 20. So what we can do now is we can subtract 10 on both sides. What I mean by that is that you have 10 here, and you have a number right over here. And if you subtract 10 from there, both sides, you still leave the equation to be equal because you're subtracting on both sides. You're not making an inequality. 5x is equal to 10. Just using the same thing I just told you before, divide by 5, divide by 5, cut this out, 2 over 1, x is equal to 2. And that is our answer. So I'm going to give you another example through the substitution method once again, and you are going to have to solve it. And as we found out here, x is equal to 2. So I'm just going to search up another two linear equations. So 3x minus 2y is equal to 14. 3x minus 2y is equal to 14. And the other one is 2x plus 2y is equal to 6. Now, these two equations are a bit harder, but I tell you, we will be able to solve them. So, the first thing we have to do here is isolate one of the variables. So, we can say, for example, that right now you're saying that 3x minus 2y is equal to 14. Now, instead of using the substitution method here, we're going to be using the elimination method. Because as you can see here, we cannot easily isolate the variable. Unlike this equation over here, y is equal to x plus 5, the equation was already isolated, and we were able to find y. But in here, we will not. So in this equation, we'll teach you, in this part, we're going to teach you how to solve through elimination. Okay, so elimination is really simple. All you have to do is just cut off the numbers. So what you can do is just say 14 minus x. We're going to assume that we are subtracting in here. So we're going to say this entire thing and negative 6. Okay, so now we're going to subtract. 14 minus 6 is equal to 8. Put the equal sign there. Negative y, negative 2y, and in fact, this just became a negative. So negative 2y minus 2y is equal to negative 4y. We're just testing to see if negative works here. Negative 4y. And 3x minus 2x is equal to x. We have just found out that now we can isolate the variable here. So x minus 4y is equal to 8. If x minus 4y is equal to 8, we can add 4y to both sides and say that x is equal to 8 plus 4y. So we have just found out what x can be equal to here. So we can apply it to the next equation. 3, and instead of x, we'll write 4y plus 8 minus 2y is equal to 14. Now, using distributive property once again, 12y plus 324 minus 2y is equal to 14. 12y minus 2y is equal to 10y plus 24 is equal to 14. Now we can subtract 24, and now we're getting negative numbers over here. So minus 24, and you get 10y is equal to 14 minus 24, which is equal to negative 10. We can see that this equation will turn out to be negative 1. So y is equal to negative 1. So we have just found out what y is, but do you know what x is? No, we don't. So we can just plug it in once again. If 3x minus 2y is equal to 14, make a new page here. Y is equal to negative 1, and 3x minus 2y is equal to 14. Substitute the value for the y, you get 3x minus 2 times negative 1 is equal to 14. I just simplified. I just substituted. 3x minus, actually it becomes plus now, because negative times negative is equal to positive. 3x plus 2, because 1 times 2 is 2, is equal to 14. Now we can subtract 2, and we get 3x is equal to 12. And we can divide by 3 on both sides and get that x is equal to 4. And we have just established that x is equal to 4 here. And we have just solved using the elimination method. Another method that you can use is the graphing method. But in this video, we're not going to be covering it. But we're going to show you a bit of a shortcut. So we're going to show you this equation. It's going to be called y is equal to mx plus b. Okay, so this equation is used to graph linear equations on a plot. And if you can plot it, each of them are going to be a line. And where the two lines intersect, meaning the two linear equations, those 2 points, x and y, are going to be your answers. And that is a really quick method for some, but it can be really hard to learn how to graph those lines. So x would be your answer and y would be your answer. We're going to be covering that in a different video. But if an equation has somewhat of this structure right here, for example, y is equal to 3x plus 1, or you can say y is equal to x plus 5, you still have the same structure here, because you're basically saying y is equal to 1 times x plus b. And the important thing to know here, y is the y coordinate, x is the x coordinate, m is the slope. So remember, slope is always y2 minus y1, meaning the second y coordinate minus the first y coordinate over, let's make that a bit clear, x2 minus x1. And if you make that as a fraction, you get your answer. And B is the y-intercept. Now, what is the y-intercept now? The y-intercept is when a line hits the y-axis. For example, if I drew a line right now, this spot right there, for example, for 4 would be the y-intercept, because you're hitting the 4 right on the y-axis line right here. So if you're able to find out every single one, for example, this one right here, y is equal to 1x plus 5, the slope is 1, so you're basically going down 1, up 1 and up 1 and right 1, and the 5 would be the y-intercept, so you're able to graph that. So I hope we have learned something in this class today using these two methods, the substitution method, the elimination method, and we have just introduced you to the graphing method. The graphing method I do not recommend to use because you will need to draw a rather nice coordinate plane, and that would be hard for some people. So again, those 3 methods, they're going to be called the substitution method, the graphing method, and the elimination method. Or, as I call it, SEG. S-E-G. SEG. And remember, whenever you find a linear equation, go to this video, relearn how to do this if you have forgotten, and you will be you will be completely free of the terror of not being able to solve a linear equation. And I hope this has helped you in some way or the other. This is the Silver Globe signing out, and remember to subscribe.